So we have code here which, when we run it, it produces a square with a different color at each corner. It divides the square into two triangles, one in the bottom left and the other in the top right, and we saw that it was tedious and a bit of a problem that we have to repeat the vertices at these corners twice, and we're going to discuss some ways of dealing that, which will lead into different ways to represent a mesh. And by the way, a mesh is just the term for breaking the object into a bunch of little faces, vertices, and basically, whenever I have to think about mesh, I think about, this scene from a Christmas story where the dad gets the lamp, and I think this is called a mesh stocking, for instance, and it comes from the way wires are linked together, like a mesh fence, for instance. Well, when we render the 3D objects, if we were to outline every triangle, it looks a lot like, say, the mesh stocking. So we call these things meshes. Very often in graphics, when we speak of meshes, we're also talking about a data structure which keeps track of the faces and the vertices, so that we don't have to store or represent the same vertex twice often. The simplest one is called an indirect mesh, and I'll show you how that works. What you do is you have to store the vertex properties in arrays, and then you can look up those properties later so that you don't have to repeat the code. It's a simple idea. So we can have a float for the actual vertex coordinates themselves. We could call them points or vertices, and we're going to have, in this case, 6 vertices with 3 coordinates each, and it's an array. So in C we can just initialize it by typing the values in. So in fact, we're not going to have 6 coordinates. We're dealing with a rectangle. We're going to have 4 coordinates. Negative 0.5 is the bottom left, negative 0.5, and 0. The next one, I'm going to do this is the bottom left, right? The next one I'll do is the bottom right, so it's at positive 0.5. It's still at the bottom, so negative 0.5 and y and 0. So that's the bottom right. The top left, since it's the left, is going to be 0. Well, let's do the top right. We'll do them in counterclockwise order. So the top right is still going to be positive 0.5, but now it's at the top, so that's a positive 0.5 and a 0. And that's the top right. And then the last one is going to be the bottom left, so it's at negative 0.5 since it's on the left, and it's at positive 0.5 since it's at the top, and 0. So we have the top left point, and a semicolon should finish that off. Curiously, in C, I don't need to say that there's going to be 4 of them. It'll figure that out. You can always leave out the number on the leftmost array dimensions. I can't leave out the 3, but I could leave out this 4. So so that would be the vertices. I can also do the same thing in a parallel array. I'm just going to call it vertex colors or V colors, since I'm slightly lazy. And I can render these in, I believe, the same colors. The bottom left was in red, and the bottom right was in green. The top right was yellow, and the top left was blue, I believe. We'll we'll see. So I can store the vertices here and the vertex colors here, and now in order to draw the faces, I can just specify the colors by looking them up. So in order to draw the first face, I need to figure out which vertex that is. So the first face is vertices 0. This is vertex 0. So what I can do here is, instead of vertex 3F, there's another version called 3FV, and I can just pass in an array. So I can pass in vertices 0, and it'll pull, instead of passing in the coordinates, it'll just pull them out of the array here. Similar for GL color 3F, there's a color 3FV, and I can use also colors 0. And it'll look them up in this array, and it'll pass them on. Right. So I can repeat it down here. So this vertex is at the bottom right, which is vertex 1, right? So I'm just going to copy and paste there, because I can replace those zeros with a 1. And the last one is going to be not 2 but 3. That's the top left, is going to be at index 3. So this face is, it starts with vertex 0, then vertex 1, and then vertex 3. This face, I'm going to copy and paste that whole thing. It starts with vertex 1, then it does vertex 2, which is the top right, and then it ends again at vertex 3, which is the top left. And we just look up the colors and the vertices from the array. I appear to have misspelled something. I got an error. Oh, this is called V colors everywhere I use it. So, and here we see the results are the same mesh, and one could argue this is a bit cleaner. We can make it even more clean by storing these indices in another array. So an int array called faces. Each face has 3 points because they're triangles, and then the first face we see down here was 0, 1, and then 3. The second face was 1, and then 2, and then 3. And in the next video, I'll show you how you can use these arrays to skip all of this.